Okay, characteristics part 2. We're still talking about the amplitude, period, and midline. The difference is we're going to actually look at it and try and figure it out from the equation. So graphically, we know what it is that happens. If you look at this graph here, blue one's the original, amplitude is 1, period is 2 pi, midline's at y equals 0. This new graph, though, the red one, now has an amplitude of 4. It's got the same midline, same period, but it's got a different amplitude that's now 4. Well, if you compare these two equations, these two functions right here, the difference is that this one's got a 4 out front. The amplitude is 4, and it's got a 4 out in front. Let's look and see if it happens with fractions. So original is blue, amplitude is 1. Now if you look at the red one, and it's not labeled, but if you look at it, that's about half, which means this is actually at 1/4. So my amplitude is now 1/4, and again, the equation changed by 1/4 going out in front. So this number out in front is always going to be your amplitude in front of the actual trig function. Cosine, sine, tangent, doesn't matter. That number out in front is going to tell you your amplitude. But now if you look down here, this one, the blue one, amplitude of 1. The red one also has an amplitude of 1. But if you look at the equations here, the difference now is that there's a number on the inside. It's next to the x, not outside in front of the trig function. So the difference between these graphs is obviously that when the blue one does one cycle, it takes until 2 pi. But this guy, the red one, he does one full cycle in pi halves, which means his period is pi over 2. Now, if you look at the period related to that 4 right there, it's not 4. It's going to become a different piece. Basically, when it has this 4 inside here, it says, okay, one regular sine, it takes 2 pi. I want you to put 4 of them in there. So the period actually was just computed by taking 2 pi and splitting it up into 4 pieces to let you know how far each one gets to go. So that's where it comes from. That 4 is what goes in the denominator. It's always 2 pi on top, 2 pi divided by whatever that number is, and that gives you your new period. Now that works even when there's fractions. This graph's a little bit harder to see. Again, the blue one's the original. Regular period is 2 pi. The red one's the new one, though. You can't even see a full cycle from 0 to 2 pi. So what I did down here in the bottom is I did a graph that was one full cycle of the red one. And if that sine were on here, it would actually look about like that and then continue on forever, right? So now we've actually stretched it out and made it a bigger period than a smaller one. This period is actually is 8 pi. The calculation's the same though. It's still the same formula, this idea of 2 pi divided by that number. Now I don't like fractions inside of fractions. So anytime I'm dividing and there's fractions involved, I always change it to horizontal. So it becomes 2 pi times the reciprocal, multiply that straight across, and that's where the 8 pi comes from. Okay, next one is the midline. So the difference between these graphs is that now it's got a -2. And if you look at the picture, the original one, now it's in the red. It's cosine, right? Started up here, ended up here. Here's the minimum. The midline is in between those guys, and it's going to be right there. But this blue one, his maximum's there, minimum's there, exactly halfway in between is right there. I mean, you can compare them, and you can see that they're the same pattern, so they're going to have the same period. Their distance from the midline is both 2, well, 1, sorry, I didn't look at the correct markings, right? That's 1. But the thing that's different is now that midline has moved. So the midline here is at -2, In the original one, in a basic sine and cosine graph, the midline is at 0. Now, look at this amazingness. It subtracted 2 from the end of the graph, and my midline happened to be at y equals -2. So that's the chain that's going to happen when you change that actual midline. It's really easy to identify. Here is g of x equals cosine of x plus 2. Well, here's the original midline. The new midline's up there at y equals +2. Originally it's at 0. This right here is automatically your midline. Notice over here for this one, there's no number being added or subtracted. Technically, it's +0. So that number that's added or subtracted, now that's the biggest difference between midline and amplitude and period, is the midline has to do with adding or subtracting numbers after the trig function. The other ones, if you look back at the period and amplitude, these numbers are being multiplied, either multiplied inside or multiplied outside in front of it. This might start ringing bells and you're thinking of transformations, and that's basically all these are. But we'll talk about transformations later when we get into actually graphing by hand. Okay, so these are the basic generic forms of sine and cosine functions. There will be one more piece to it, but for now we're just going to deal with this type. Okay, 3 variables here, a, b, and d. This number out in front, you remember when we multiplied by 4 out there, or 1/4, it changed the amplitude. So when you look at these equations, whatever that number is out in front is the amplitude. But if you notice right here, there are absolute value bars around the a. What that means is the amplitude is always positive. Amplitude is a distance from the midline to the maximum or minimum. Distance is always positive. There will be sometimes a negative out in front of that a. That is not part of the amplitude. That has something else to do with the graph. All right. So this example over here, g of x equals cosine of 2x minus 4. If I asked you to identify the amplitude, you're looking for that number out in front. There is no number though. But then that superhero 1 comes in and says, look, there's nobody there. I'll stand in place so that you can see someone. Amplitude is 1. Bam. All right. Next, let's talk about the period. Period relies on the letter B. That's this guy. So that b that's inside being multiplied, it's right directly next to the x. It's how you're going to compute your period. Again, it's in absolute value bars. Period, again, will also be always positive. But it's just this formula. So the p is always going to be 2 pi divided by whatever that b number is inside there. So in our example here, b is 2. Which means to compute our period, we're going to take 2 pi, always 2 pi, because that's the period of the original sine or cosine function. So for this example right here, our period is actually just pi, which means on a graph, one full cycle of this guy would happen from 0 and it would end at pi. What people. All right, last one, midline, easiest one on here. Whatever number is being added or subtracted outside the function. The a is multiplying, it's touching the function sign. B is multiplying, it's touching the number x. This plus or minus d, this value that's being added or subtracted, is automatically your midline. Plus d, that means it's a positive number. Minus d, minus a number, it's going to be y equals that negative value. For example, this guy right here, the midline would now be at y equals -4. Okay, let's try the next one. Looking at this one, I've got this number out in front of the trig function. That gives me my amplitude. Right, let's go to midline next. Midline deals with this number right here. So my midline is going to be automatically at y equals 2. Now that y is important. Midline is an actual line. So just telling me that a line is 2, that doesn't make sense. You have to actually say y is 2 so that they know it's a horizontal line. Okay, blue for period. Again, period is a formula, 2 pi over b. You have to identify b, and that's the number next to the x. 2 pi divided by 1/2. Again, fractions, I hate writing them as a fraction and a fraction. I would rather write it out horizontally. So 2 pi times, flip the 2 over 1, and our period for this guy is 4 pi. Okay, let's look at some more. Right, identify the amplitude period. Oh, we're not doing the domain and range yet. We're doing the midline. Okay, identifying our numbers. Let's start with amplitude. There's no number there, so you're going to assume it to be a 1. That means our amplitude's nice and easy. It's a 1. Okay, let's go next with midline because that's the second easy one. It's going to be y equals, and then it's just this number that's being added or subtracted on the outside. Right, then we've got period. Period is 2 pi divided by b. In this case, that b is a 4, which equals pi halves. Done. Next one, again, amplitude is this number that's out in front. So my amplitude is going to equal 2. Midline is also very easy, so we're going to look at this one. Midline is going to be at y equals 5. And then our period, again, period equals 2 pi divided by b, but my b is 2/3. We're going to do 2 pi and then horizontally divided by 2 over 3. Keep the first one, change to multiplication, flip the second one. That's 6 pi over 2, or 3